Welcome back to ArmanisMath. Today we're going to be talking about the Cartesian coordinate system. Here's the warm-up. I'll give myself about a couple minutes for this. So here's the timer. Please do the warm-up. It helps you focus on the topic ahead. I'm not going to wait until the end of the warm-up. However, I'm just going to stop the timer. You guys could stop it yourself. Here's some answers for the warm-up. Some of these you don't need the calculator for. They're just giving you in a decimal format. You could just leave it in radical format as well. Like this one here, square root of 3 squared plus 5 squared. That's 9 plus 25 square root of 34. That should be fine as well. Alright. This one here could also be square root of 34. The objective today, I will be able to use the Cartesian plane, the distance and mid formulas, the equations of the circle, also use the properties, also use the properties of the absolute value of a real number. I just want to mention that we have our Cartesian coordinates, the one that we're accustomed to, the x's and y's is the x-axis, positive x and positive y's. Obviously negative x, and down here is the negative y's, negative y. And what's important about the Cartesian coordinates is divided into 4 quadrants. We use Roman numbers for these. For example, this first quadrant, which is 1, and the second quadrant, the third, and then the fourth quadrant. By the way, you read them counterclockwise. Counterclockwise, that's a default rotation. So this is first quadrant, second, third, and fourth. Obviously, points in the quadrants is going to depend on its location and the sign that they have. It's positive or is it negative? I'm going to take an example in a second. So for example, whatever I want to say, where is negative 3 comma negative 4? Which quadrant? Well, it has to be here somewhere, right? Negative 3 comma negative 4 could be here somewhere. Negative 3 comma negative 4 lives in the third quadrant. So it lives in the third quadrant. The midpoint formula on the number line. So I'm going to pretend I have a number line and I wanted the midpoint between the two lines, between the two numbers. So this is 0, this is negative 2, this is 8. I know the distance. How long is this distance here? Well, I have this formula at the top. A plus b over 2, so I just label things. I'm going to label this A, label this point A, this is point B. So all I have to do if I want to find the midpoint between them is maybe I want to do like midpoint equals A negative 2 plus 8 over 2. Negative 2 plus 8 is positive 6. So the midpoint will be 6 over 2, which is 3. Is that right? Well, let's check. I've got 2 units here and 8 units here. That's 10 units. So if you counted 1, 2, all the way to 8, you'll find yourself that actually you are in the middle. My grid is not drawn to scale here, but you find yourself in the middle somewhere here where the 3 belongs. So that's the midpoint on the number line. How do you find the midpoint between two end points of a segment? So basically, how would I find the midpoint between 2 points on the Cartesian coordinates? Let's actually take an example here. So what I have to do is label my points A, B, C, D, and then from there I'm going to use A plus C. Basically, you're saying the x of the first one plus the x of the second divided by the 2, and then you're going to say the b of the first and the d of the second, the y's, divided by the 2. So basically, you're averaging the x's and you're averaging the y's. Here's an example. Find the midpoint between 2, 3 and negative 8, 4. So I'm going to use that same strategy. As I said, some other formulas have it in terms of x's and y's. Ours use the a's and b's. It doesn't really matter, it's irrelevant, but you could obviously do that. So either way is fine. You could label x and y and then use the average of x's divided by 2, average of y divided by 2. So this is A, and B, C, and D. And all I'm saying here for this example, I'm going to just have the midpoint equals, once again, you're averaging the x's, you're averaging y. So 2 plus negative 8, that is over 2, comma. Remember, if you're on the Cartesian coordinates, the midpoint has to be a point, not a number like on the number line. It's a point. So and then I have myself the b and the d. B is 3 plus the d over 2, and that should give you, we did this before, right? That's a negative 6 divided by 2, that's a negative 3. We did something similar to it, negative 3, and then comma, I have 7 over 2. Now you could leave it at 7 over 2, or you could say that's 3.5. So also negative 3 or 3.5 if you like. That's another way to do it. But that's the midpoint. Remember, midpoint in the Cartesian coordinates is actually a point, not just a number as in the number line. Now, do you find the distance between 2 points? Distance between 2 points. Well, if you want to find the distance between 2 points, there is a formula for that, which is right there in front of you. And the formula goes like this. So if I have a Cartesian coordinate that looks like that, and a point here, for example, and a point, let's say, here, how do I find the distance between them? Not the midpoint. This is the distance between them. How far are they apart? So somebody can say, I could count. Well, you could count if you're vertically, right? Or horizontally, straight lines. But you can't count if it's a line or a slanted line with a slope. You obviously could argue you could use the Pythagorean theorem. Well, guess what? The Pythagorean theorem gives you actually this equation here. So that's why we're using this equation. Okay, so basically you have to label your points. And it doesn't matter which one is point 1, point 2, as long as you stick to your choice until the end of the problem, you should be fine. But the distance formula is the square root of the difference in the x's squared plus the difference in the y squared. So let's take a look at an example here. Find the distance between 2, 3 and negative 8, 4. So once again, I'm just going to label my points, x1, y1, x2, y2. And I'm going to use the distance formula here. So distance equals, I have x1, which is 2, minus negative 8. Maybe I could choose a different color for these guys. 2 minus negative 8. Okay, square, the whole thing squared, quantity squared, plus got the y1, which is 3, minus y2, 4, and that is squared. All this is under the square root. Okay, so I've got d equals square root of, what is 2 minus negative 8? Well, that's 2 plus 8, that's 10. 10 squared is 100. And I've got myself 3 minus 4, that's a negative 1. Negative 1 squared is just a 1. So basically I am looking at distance of 101. Distance equals square root of 101. It's almost like 10, but it's not exactly 10. Okay. Moving on to the circle. Standard form equation of the circle looks like this. X minus h squared, y minus k squared equals r squared. H and k being the center of this circle, and r is your radius. Alright, so that is, by the way, also you could, that center could be the origin, the 0, 0, which is totally fine, which means in this case it's going to be 0 for k, which is x minus 0 squared plus y minus 0 squared equals, let's say that you have a radius of 2, for example, and this 2 squared. So that's x squared plus y squared equals 4. That's a circle at, or centered at, 0, 0, with the radius of 2. Now what happens if you have different center? Well, let's take an example. It will be this one here. Find the standard form of equation of a circle with a center of 2, negative 3 and radius of 4. Well, I'm going to use the same formula again. Before I do the formula, I'm a big fan of labeling things. So here's h, here's k, here is my r. So basically what I'm saying is x minus h squared plus y minus k squared equals r squared. X is just the x minus h. Well, that's the center. Remember the horizontal part of the center, or the x part of the center, which is 2 squared plus the y minus negative 3 squared equals the 4 being squared. Use parentheses, it's going to help you. So x minus 2 squared, that's going to be just x minus 2 squared. Remember, you want it in the standard form. That's why I'm leaving it the way it is. Down the road, we're going to do something to that. But for now, that's the standard form. 16. This is the standard form of a circle that is centered at circle, centered at 2, negative 3, with a radius of 4. Okay. Here it is, nicely printed. Okay. A second here. Oops, I got too far. Whoa, whoa, whoa. All right. What about the properties of the absolute value? I'm not going to spend too much time here, but you should know that the absolute value is a positive function. So anything you stick into it here, anything, like, it's going to be positive. That's what it says, it has to be positive. There's no absolute value of x, for example, equals a negative number. That doesn't exist. Why? Because the absolute value is the distance. Distance is measured in positive. You can't say I'm driving to the mall 5 miles to the mall, or I'm driving to my next subway, my closest subway will drive like negative 2 miles to my negative subway. That's not going to happen. So that's why distance is always positive. Keep that in mind, okay? Positive distance. Also, we know that, for example, let me actually give you some examples on these. So the first one is always positive. if the absolute value of a number, a and b being real numbers here. Let me actually do one thing at a time, not too many things here. No, one thing at a time. So you know that, again, the absolute value gives you a positive value. The absolute value function gives you all a positive. And an example of this property where the negative of a real number in the absolute value will give you its equivalent also on the positive side. So the absolute value of negative 5 is exactly the same as the absolute value of 5. Again, distance from 0. You're saying from that midpoint, how far are you going this way? 5. How far this way? It's also 5. Distance. That's why they're equivalent. How about this one here? What if I said a times b in the absolute value? It's going to be the absolute value of a times the absolute value of b, which means you can separate the absolute value here if you're multiplying what's inside. So 5 times 2, for example, is the same as the absolute value of 5 times the absolute value of 2. The absolute value of 5 times 2, you could separate that to give you absolute value of 5, absolute value times absolute value of 2. What about division? Well, same thing. When you divide the absolute value of a divided by b, well, that's going to be exactly the same as the absolute value of a divided by the absolute value of b. Obviously, being not b being not a 0, since that would be undefined. So, for example, the absolute value of 8 over 5 as a whole fraction equals the absolute value of 8, the top of the fraction, the numerator, divided by denominator, which is the absolute value of 5. So that's another property of the absolute value. And this should conclude our simple lesson today on the Cartesian coordinate system. Remember, as always, we do not lose hope, and we are trusting that we're going to help each other through the pandemic, and obviously depend on the help of God throughout life. I'll see you guys next time.